3 creates very fast. There it says 3 at the top, 2 at the top, and 1. Hey, Daniel here, aka HashLips, and welcome back, guys, to an exciting video, an extension video on the generative art code that I did in Node.js. Now, as you can see from the repo alone, there's a lot of people who actually followed along this tutorial and had a lot of questions for me. So one of the questions was, how can you make and ensure that there's a uniqueness in the IDs that's generated? How can you write on the NFT, like with text, maybe putting the edition number or so on? And how can you batchment? And the problem to that batchmenting was that the program was too slow. It started using too much RAM, and we're going to solve all that right here in this video. So I hope you guys are going to enjoy this series, because this is really going to make this generative art code much more slick, much more beautiful, and also will help you in your project. Please remember to like, subscribe, and comment in this video if you enjoyed it. And I'm going to put a special request out there from this point onwards. So after I've created this video, I'll upload this repo to this Github account, and I'll call it an open source generative art project. And I want you guys to contribute to it. We can add things on there, such as more stuff like rarity and all these cool little things, but I want to make it an open source project for you guys to do, to follow along, to contribute to, and who knows, we will take this thing into the future, into 3D space and all these kind of things. But we have to get the basic concepts down before we can go and elaborate on any of those other platforms. So let's jump into it, and the first thing that I'm going to do is just show you briefly how to spin up the original one. So let's take a look at the previous project that we did. You can go to github/hashlips and then go and select the generative art node project. Once you're in here, go to code and copy the link. Then go to your favorite IDE, and in the terminal type in git clone and paste that link. That's all you need to do to kind of get this project onto your machine. Once this is done and cloned, you will see that you will have a folder in your IDE. We have to navigate inside that folder, so you can go cd. I think it's the same on Windows, I believe, I'm not sure, but or directory. You just go to this directory basically, but on Mac it's cd. Generative art node, and we're in the directory. You can type in ls just to make sure, and you'll see all the files, or you can just expand it over here. Once we're at this point, we need to do all the installations. So you can do this using yarn or npm. So I like to use yarn. I just say yarn add all, and that's enough to go and tell the computer to go and pull down all the dependencies that it sees in this package.json file. And we don't have a lot of dependencies, we just basically have this canvas, right? The rest of the folder structures you all know. I'm not going to go through it. If you want to know about this, go and watch the previous video tutorial on how we created this from scratch. This is going to be an update on that. Next, after everything is installed, the only thing you need to do to run the program is you can open this output folder to see that nothing is in there, and you can run node index.js and then the amount of NFTs I believe you want to create. So if we want to create 2, we can say we want 2, and it would start generating and outputting in this folder. Now you notice that it's kind of slow, and the thing is that's because it's loading these images in memory, and it's loading it in RAM, and basically has to keep track of it, and it's not asynchronous. It's a weird explanation for beginner coders, but what we're going to do is resolve this problem. Anyway, looking at the 2 images that was added right here, we can open it up and we can see that there's 2 eyes created. If you want to know where the eyes came from, it came from a bunch of layered files sitting in the input folder. Again, go and watch the previous tutorial if you don't know what I'm talking about here. Next, I just want to show you something. If you click on the metadata.json, and a lot of people had a question, how did I organize this? I use a plugin called Prettifier, and that helps me when I say Control Save. It bundles up all the code nicely in JSON format for me. The one thing that we're going to start off with is cleaning up our configuration file that we did in the previous video. This is way too much metadata for an NFT. And we're not going to focus on purely NFT metadata because this is just art metadata, but I'm mentioning the word NFT because this is usually what this program is used for. But it can be used for a numerous array of things. But anyway, this is too much metadata, and we're going to clean this up in this series, and we're going to perfect this code a bit more. Like I said, I'm inviting you guys to this open source project after I've released this video, so go ahead and contribute. But you've seen this now in action. You've seen how easy it is to spin up the old application, and for now we're going to look at how we can clean this code up and start perfecting what we already have and make an awesome generative art code program. So let's go to the index.js file, which is the heart of the application, as you guys know. We're going to scroll down to the very bottom where we actually see where the minting takes place. And if you look at it, it basically takes place here. Now we're going to expand on this a bit, because the thing is that we need to add some beef to this. We need to make it much more efficient. So I think what we can do is two things. We can put this in a function that's actually going to be a bit more meaningful, and then call it. So let's go and do that. I think what we'll do is we're going to call this function. So give it a bit of space. And what we want to do is in this function, we're going to just say start creating. We'll just call it start creating. And the reason for this is because seeing that you guys love this code so much, it makes sense that we actually start putting it in different functions, making it a bit more pure, and also just following a bit better coding conventions. I think you guys will like that a lot as well. Next, we want to put this piece of code, this loop, inside of this function, and then we want to call it right below here. So start creating, and this should act the same. I advise you guys that each step that we take, go down here, and at the intervals that I suggest, go and mint one NFT or one artwork. Go and create one and see if the code still works. Because the code needs to work. As soon as it breaks, you at least know where you went wrong. And that's usually a practice that I follow. I also follow the practice of console.logging everything out. All right, so perfect. The next thing that we also want to do that can kind of clear this up is this function below. It really doesn't need to read the metadata first. It can simply just write to it. Writing to the file will overwrite its contents and also make sure that our metadata is in there. So what we can do is above this start creating function, let's create another function, and we're going to call this const write metadata. Okay, and let's do that. We're going to add this function just to simply put this in there. But we're not going to put the whole thing in there. We only need to get access to this line. So I'm going to cut that out, and I'm going to paste that inside our write metadata, and then I'm going to simply just delete the rest over there. Then I'm going to call the write metadata right after, well, not right after start creating. We're going to call it somewhere else later on, but for now, just leave it there. I want to do this in a step-by-step manner so that everyone understands what we are doing. Perfect. Once we at this place, everything is still working. We can run it below here. You'll see everything is still working. Nothing is breaking. But the very first thing that we need to solve is how do we kind of make sure that our things are unique, what we create? How do we make sure that the IDs, for instance, if we go into our metadata here, I'm just going to click Control S to format this. You might need to set this up on your machine to format, but needless to say, how do we get these hashes to be all unique? Now, there's two problems that we are facing. The first is that every time we run this program, and especially in batch minting, we need to save these variables somewhere. But what if we can make the minting process, the creating process, so fast that we don't have to save the data in a different file? Instead, we can make it optimized enough to mint at high speed, so we don't have to actually go and read other files. We can do it all in this one call. Well, that's what we're going to do exactly. Actually, we're going to do optimization, making it fast enough so we can actually check these IDs inside of our program. Now, the first thing that we'll need is kind of an ID field that we are going to be working with. So let's go to the top and let's go and create that. So you can say var DNA. So we're going to work with DNA, and we're going to call this DNA list. Okay. We're going to give a bit more descriptive names to what we are doing, because I realize that some of these names don't make sense and we want to be as good as we can. So we're going to create a variable called DNA list, and also just for best practices, make this maybe a let variable. I might leave it as vars, but let is just fine because it's in the scope. Let's leave it for var. Let's leave it var for now, just to keep that the same. But generally, you need to consider scope when coding as well. Next, what we can do is scroll down again to our other function where we create minting, and we need to kind of now decide how this program works. So first things first, let's comment out the part that actually creates the images, and let's look at our loop. This loop will not work, and the reason for that is because it's going to loop a number of times and it's going to kind of just execute an increment. We want to change this in a while loop. Now the thing is, you can make the for loop work, but I think a while loop is much more cleaner and best suits our use case. How do we do that? Let's go and change this into a while loop. So there's a simple thing we can do. We can create a variable here at the top and call it let. And this time I'm going to call this addition count. We're going to initialize the addition count to 1. Then what you want to do is change this into a while loop. So you will say while, and a while loop is pretty simple. While a condition is true, it will keep on running. So this time you want to say while the count that we've just created is smaller or equal to something. Now this something is the addition. Where do we get this addition from? Well, at the top of our page you can see that addition comes from our arguments. When we run the program down here and we say node, index, and a variable, that's the addition size. Okay, if we don't specify that, it would automatically fall back to 1. But we actually want to give a better name. So this addition, we're actually going to look for it throughout the app. You can press Command F, and we want to change the addition to addition size. But we're not going to do it there. We'll just manually do it. So let's type in size. And let's go and look for the rest. So there's the addition size, and also I'll just replace that, even though that's a console.log. That's fine. I think it's only those 3 areas where we're doing it. And remember now, in our while loop, we want to check if the addition count is less or equal to our addition size. And that is perfect. Now, in order for a while loop to actually work, what you'll need to do is you'll need to increment this at the very bottom. So that's actually how a while loop works, and that's all it takes basically to make a loop work. So let's test this out. Let's test this loop out. What we can do now for just for time being is remove this code, but actually take the code that used to be inside the loop and just paste it here above where the addition increments. We're going to get to this just now. For now, I'm just going to console.log. So I'm going to say console.log, and what we want to log is actually, let's just say, this is going to be the addition, and you can use string interpolation here, and we're just going to do the count. Okay, now let's run it down here. So we're just going to run it as 1, and you'll see that it prints out addition 1 down there. If we do 4 or 5, you'll see that it loops and it does 1, 2, 3, 4, 5. What happens if you don't increment it? Well, your program will go into an infinite loop, and that won't be good because then it will not stop execution. So you always have to increment the count. But this brings us back to, why do we want a while loop? Well, now the thing here is we want a way to check our DNA. And we usually, how we did the DNA or the hashes before, is we got random layers, and the layers selected themselves, and then it basically added to a hash. But now we're going to refer to it as DNA, and we have to create the DNA now so that we can check it in a list, basically, to make sure that the DNA is truly unique. So let's go ahead and do that. Now let's create our DNA. So what we can do is create a new function. We're going to call it const create DNA. Perfect. And what we are going to do in this program and focus on is more of a pure function-based execution or creation of functions. And I'll explain that in just a second. What I mean by that is we're going to try and pass arguments to our functions that the function utilizes inside. For instance, if we had to use the DNA list, and the DNA list sits here at the outside of a function, you can indeed use it inside the function, but we're going to do a better practice of passing it in as an argument in our function calls. I'll explain that when we get there. But for now, what we want to do is we want to see how can we create a DNA, a unique DNA. Now, this is going to sound a little bit complex, but stay with me and you'll get what we're going to be doing. First, we have to say we're going to create a rand number. So let's say we want to create a random number, and we want to create a number that looks like this. All right? Specifically, we want to create a number that is actually 14 digits long. And why 14? Well, if you look at our input folder, you'll see that we have 7 different folders. And because we have 7 different folders, we would like it to be 14 digits so that we can take and split these this DNA into 2s. So later in our program will split 67, 32, 61, 47, 81, and so on. So I think you get what I mean by this. Okay, so there's a bit more digits than 7 here, so we only need this much. So that's kind of the length of what our DNA should look like. Now, how do you create an actual number that is exactly 16, that's exactly 14 digits long, but it's a random number? Well, it's very simple. What you can do is you can do this. So we can use math.floor. And what we want to do in math.floor is we want to give it a number, which is going to be, it can be 1. So, but I'm going to start off with 10, okay? And then we add it to a math.random function. So the math.random function chooses a value between 0 and 1. So what you can do with that is you times it by a number. Now, if you times this by 90, 10 plus 90 is 100, okay? And it might not make sense now, but this in between is a times this by the 90, right? So if you can imagine, this would be something like 0.6, for instance, okay? So you can work this out, and it will always give you a number of 2s, right? So for instance, what I mean by this is if we, for instance, say, okay, cool, so give us this number, and then we want you to log this out. So let's console.log the random number. Perfect. So now, just end that there. So now let's call this. Okay, we're gonna console.log now the random. Okay. And we're going to execute it. So we're just going to call this function. This function will return to us a random number depending on how many additions we have, right? Because it's in the while loop. So let's go and create 5. And there you can see. So it says 10, 95, 50, 81, and 10. It created a random numbers of 2 digits. Okay? So that's the basic principle here. I see that it says random numbers undefined. I don't know why it would do that. Let me just think about this. Random number is undefined. Oh, okay. It's because we're not returning anything, right? So we actually have to return the random number up here that we are working with. Okay, so we don't have to console.log it there. We can just return this and just make sure it's the same as that. And then if you run it, it will actually log out random 34, 16, and so on. But you can see we are creating random numbers of 2 digits. Now, what will happen if we increase this number in the beginning with 1 digit and this one with 1 digit? We will create a random number of 3 digits each. So if we run this again, you'll see that we have 700, 700, 200s, and you know, it's random, but the most important takeaway is that it's 3 digits. Perfect. Now, because we want we have 7 layers, and we want to make sure that we have double 7, so 14 digits, which we're going to split into 2, 2, 2, 2s for our DNA later on. We want to create that. So that would mean that we would need basically 14 digits here. So we already have 3, 4, 5, 6. That's what we would need. And we would also need the same on this side. Apart, we need a 9 over there. So when we run this, you will see that we get 14 digits basically in random numbers, and this will be our DNAs. How cool is that? That is what we want to do, but we want to do it in a bit of a better fashion. Now you can do this and writing it in a bit more mathematical way, I would say, and that's by writing E13 over there and the same over here, right? E13 just basically means how many zeros there are, just to plainly explain it. And if we run the program again, it gives us the same result, obviously with different random values, but you get the point. All right. So we need to kind of make this dynamic though, because what if you in your project only have 3 layers and I have 7 and someone else has 4? We can't give this program to them because they'll have to go and update this variable, which is totally fine, but we are coders. We don't want to struggle. So we're going to do that dynamically. So what you can do is pass a variable called length. Okay, so we're just going to call it length. And we are actually going to wrap this in a string. We are going to use the same kind of concatenation here. Concatenating strings like this. Okay, and I'm first doing it like this and slow so you guys understand what I'm doing. So basically we're doing this. So technically this should still work. If we run it again, it doesn't work because I'm forgetting something here. I need to pass this, otherwise it's not going to know what it is. So I have to say this is a number, right? Because we need to pass it as a number. So you can say pass int or whatever you want to do. I just like using number. And once you've done that, basically this will work, okay? So there we go, we get our numbers again. But now we can make it easy. We can replace the 13 with the length and that with the length, meaning that this function requires us to pass in a length. Now, if you think about it, we already have the layers object here at the top, okay? And the layers, if we just take a look at the config file, layers is an array of how many objects? 7, right? So the length of that would be 7. So basically what we can do is now, let's go down to our calling function. So in the create DNA, what we want to say is layers.length. But now, interesting enough, we need it to be 14. So let's times it by 2. And I'm going to show you that there's something that's not working when we run this now. We can run it, but you notice that we get an extra digit here at the end. And the reason for that is because we times it by 7, we times it by 2, right? But 7 times 2 gives us 14, and we saw that we only have to append 13 zeros, so we actually have to, here in line 77, minus 1. And then, there we go. This is very dynamic now, and it will pick up automatically how many layers you have. Just as an example, I'm going to go back to the configuration file, and I'm going to remove 2 extra layers from this layers array. I'm going to save the file and just run the project below. You'll see that the DNA lengths get smaller in length, and that's exactly what we want. We can even take away more layers. We only have 3, so we technically should only have 6 digits. And there you go, 6-digit DNAs. So this is very dynamic. I'm going to undo what I've done here. Perfect. I'm going to go back to the index.js. So now we had a very good space where we've created a DNA from kind of all the layers and from a random string, and made sure that that length is going to help us in the future to split it up in 2 digits, and then match a layer to that section. Okay, so now that we can generate random IDs, we're pretty proud of ourselves, and we can generate as many as we want for the edition size we want. So we can do 100 if we really want to, and there's all of our IDs, right? Pretty cool. But we're not going to do 100. We're going to stick to examples of 5. It's manageable, and we can read it in the terminal. Next, we want a way to kind of find out if an ID is unique, right? And that was the whole point of doing this little change. So if we go up here, right above the create DNA, let's create another function and call it is unique DNA, or is DNA unique rather, because this is a question we want to ask, right? Perfect. So let's do that. Now we have this function. Now we need to pass in 2 parameters in here, and as I mentioned before, we are going to try and make this pure. So we're going to say we need a DNA list of some sort, and you can make it more generic by saying you just need a list, but I'm going to say DNA list to be explicit, and we want the DNA that we're going to test. For this function, you can give a argument a default value, and we do this so that we can write functions to an array, the underlying structure. Okay, you don't have to put it there, but it's just there for good measure. So next we want to return something, and we want to return a true or a false value, because if we call this function, we want to know, is this going to be unique or not? Okay, so we need to return true or false. So how can we get that? Well, just as an example, you can kind of filter through an array and match it to something, and if there's a match, it will give you a true, and if it's false or it doesn't match, it will give you undefined. So what we can do is use the find feature in the array. So we will have to say DNA list dot find, okay, and then we're going to pass it I just to give it a variable name, and we're going to say I, which is now filtering. So find filters through the array, so you can imagine that find is a DNA in this list, okay, and we're going to say, well, if I is equal to the DNA, okay, if it's equal to the DNA, this alone will return a true or false. So let me do it a bit better. Let me write this in here, and let's give this a variable name to say is or found. Okay, I'm going to say found DNA is equal to that. This will either give us undefined or it will give us true. So all we need to return here is found DNA, and we don't want it to be undefined, so we can return a ternary operator where we check if it's undefined. And if it's undefined, well, we basically want to do this, sorry. Okay, so we want to return DNA if DNA is equal to, sorry, I got confused for a second there. Okay, cool. So if it's equal to, then we want to return true, else we want to return false. Okay, think about it. So if this that gets returned, right, this is going to give us a true or undefined. If this is equal to undefined, right, we want to say it's true, right, because we want to say that this is indeed a unique DNA, and if it's not, it's false, meaning that it's founded. There is something in there which it will say this is not unique, pause the program or do something with this DNA. We don't want it. All right, so I'm going to take this function now, and we're going to scroll to the bottom, and this is what this is the magic of the while loop. We can now put an if condition in here and open the brackets. Okay, so let's just say if 1 plus 1, okay, 1, not 1 plus 1, but if 1 equals 1. If this is the case, 1 equals 1 will always be true, meaning that everything in this if block will always run. So if we place our code in here now, we will not really have a smart program in a while loop, because it doesn't matter what the condition is. It will always create our NFTs, and it will always increment, right? But there's a smart way of doing this where we can only increment once we have found once the DNA is not found in our DNA list. Okay, and how do we do that? So first we need to do is, like I mentioned, copy the DNA. Is DNA unique? And we're going to match it to our DNA. So what we want to do is we want to actually now create our new DNA first. So right above this console.log, well, below it or above it, you can say this is our new DNA. And our new DNA is going to be exactly the same as this. So we can cut it out, actually, put it there. We can move this console.log below it because we probably want to log it out just for in case, so we want to see our DNA. Then we want to take our new DNA and we want to say if new, not new DNA, we want to say if DNA unique. So not if, is DNA unique. And then we need to pass it in a list and a DNA. Remember, we specified a DNA list and the DNA. If you scroll up to the top of your file, we've created the DNA list, and this is what we're going to be using. So we can now pass that in, is DNA unique? We're going to say DNA list, and the DNA that we want to check against is the new DNA. And that's what you need to do. So what this is telling us, everything in here in this if statement will run if the DNA is not found and is unique. Currently, it will be always unique because we're not adding to the list. So we need to kind of add to our list to make sure that our DNA, will update as we go along. Now, there's a few places where we can do this. We can either do it in the minting function or wherever we want to. But a good place to do it is maybe right after here. So we can say DNA list.push, and we want to push the new DNA, because now that we've pushed it, we're actually done with our function. So now we say, cool, this DNA is created, so push it in there. And then the last thing that we want to do is actually increment our counter in the if statement. And that's very important. We want to only increment the counter in the if statement. And I'll show you now why. After the if statement, you can add an else, and maybe here just console.log DNA, I don't know, exists. All right. So we're just going to put that there, and we're not going to put anything in this function. So let's think about it quickly before we move forward. We have a while loop. It's going to run through this whole piece of code. It's going to create a new DNA for us. It's then going to go and it's going to console.log the new random DNA that we've created. It's going to check if the DNA is unique. And only if the DNA is unique, we want to create our layers and our image. Then we want to push the new DNA to the DNA list, which is here at the very top, adding to this array so that it's there and saved. And afterwards, we increment the counter, which means it will exit this loop and come back in with a higher addition and run again and run again. If this condition, the if statement is DNA, is not met, and if it's comes back as true, so if it's false, if it's not unique, then it's going to go into this else statement. It's just going to log out DNA exists, and then it's not going to increment. So it will keep on looping until it found a DNA that does not exist yet. How can we test this, and how can we actually illustrate this in a nice way? Well, I think to test this, it would be safe to say that we can maybe console.log two things here. So let's console.log the random number, okay, and let's console.log the DNA list. Perfect. Then inside this loop where all this commented code is, I'm going to do another console.log, and here I'm just going to say created. Okay, so this is going to be created, and then that's going to be the DNA list. We probably don't have to have the random DNA at the top anymore, so I'm going to take that out because we just want to see what is our list now, did it create one, and then the next time it loops, it's going to give us the list, did it create one, and so forth. So let's run it 5 times. And there we can see, this is what's happening. So it's saying, cool, this is the DNA list, which is not true. So just change that to DNA list. Perfect. Let's run it again. That's much more like it. And you can see over there. Just a trick, if you want to see the array a bit better, I would actually recommend just console.logging it out without putting it in any of those string interpolation kind of weird things, you know. But anyway, let's look at what we are logging out. So we're saying created, we've created an ID image with the ID like this. And there it is, it's added to the DNA array. Next, we create a random DNA and it's minted, right? It's created, meaning that there was no match in here because there's only that one. So it adds it. The next time it does the same, and it does the same. And it will do that as long as it doesn't find a match. Now, how will we be able to test this out? Because this is quite impossible, because this many variations is very, how can I say, difficult to find a match and see our else statement working. Well, we can do that by basically going and minimizing the amount of layers that we have. So if I go and I take away almost all of the layers and I leave but, let's say, 1, let's see what's going to happen. We are going to create DNAs that's only 1 digit, but we will most likely find a match and it will skip it. So let's see. Okay, well, 2 to be precise. So see, the program is too smart and fast for us to even find a match. So I'm going to up this to 100 digits. There we go. And you can see what's happening now. So now what will happen is it skips the loop and it goes ahead until it doesn't find exactly what it's looking for. So let's just execute. We'll close the program now. Let's go ahead and go to the very top. There's so many logs, I can't even go to the top. But basically, it found a DNA and it exited the loop, basically, right? So it exited the loop and it tried to create another one, and it checked, well, is there another one? Is there another one? Yes, there isn't. There is another one. So basically, this held all the possibilities for kind of this length of digits, right? So this will become much more harder for it to find a one that's existing. And truly, if you're creating a NFT collection or an art gallery collection that's more than 100 pieces, and you have a lot of data or DNAs that you are creating, so basically the more layers you have, the less likely it is that you will ever find DNA that exists and that it goes into this infinite loop, because it will most probably just try and create one until it has one, and you'll be fine. An example of this is if we go back to the config file and I undo what I've done just now and I leave all of the 7 layers over there, perfect, and I run the exact same command, it will do it with ease, and it doesn't even find one match. Because it is so, how can I explain? It's so difficult to find a match. And that's why I explained that it wasn't really necessary to even put this inside the code previously, because it is very difficult to find a match. It's like almost winning the lottery. But anyway, having this in your code just gives you a much more peace of mind. So we have implemented now the unique IDs, and we made sure that it is unique. The next step is we're going to go in and see how can we now render our layers a bit better. Previously, we rendered our layers in a fashion where we had to loop through all the layers. So if we just open this code again, and I'm gonna actually try and run this. I'm gonna run it with 2 and just see what happens. I don't know what will happen. But basically it doesn't break. There we go. It's created these 2s. I'm just going to run it again just to make sure. And there we go. It ran it, but it didn't save it. I don't think it saved it because we messed around with the code too much. But anyway, what it does is, if we give us a bit of space here, what it does in here, it loops through the layers, right? And then for each one of these layers, it calls this draw function, passing in the layer. Then it goes and selects an element, and it goes and adds to attributes, which this should actually sit at the bottom of the function. But anyway, needless to say, it loads the image and it draws. Then we have to click Save Layer. This is really a big problem, because every time you call that function, it writes and uses memory to write a layer to an image. So technically, in the previous version of this code, it would create a file like 1.png, and it would write 1.png 7 times over, depending on how many layers you had. And that's a problem that we can avoid by only writing to it once. In order to do that, we'll need to make use of promises. We need to make sure that the images have already loaded, and then only we can draw them on the context and save them. That's what we'll do next, and I hope you guys are excited to see that, because now we're done with the unique ID part, and now we're getting into optimization. So at this point, if this is getting a bit technical, I am sorry, but this is kind of how we can optimize the code a bit more, and it is going to get a little bit more technical before it eases down. So let's just stick through what we're going to do next and what we need in order to make this a successful program. So, okay. At this point, we want to start drawing our layers. But like I explained before, we've got a little bit of a problem. In our current draw layer function, which is this one, we have a problem. We're busy loading the images and waiting for it, which is true, but then we're saving it immediately. We need to kind of split these two, well, this code into two different functions. So let's go ahead and do that. Right underneath this function, we can create a new function and call it draw. And let's call this draw element. And the reason why I want to say draw element is because now we're looking at what element the layer has selected. This will make sense in just a bit. The next thing you can do is actually copy this whole draw function and put it in here. Now we need some kind of parameters which we'll get, which we're going to pass in the element in here. And what we can then do is we need to kind of get this now from get this information from this element. So we need this function to take this element, and it should give us all these kind of nice things. The last thing that you want to do is just grab this add attributes, and you can actually cut that out of there and put it here below this draw function. Here we're also just going to put the element and not the layer. Perfect. So now that we've split this up a little bit, we can basically take this part out of this function. And the next part that we can do is rework this function to work a bit better with what we want to do. So now, instead of us calling this the draw layer, we need to call this the load layer. So I'm going to say load layer, I don't know, load layer image sounds fine. And then what load layer is going to do, it needs to be asynchronous, so that we already got fine. We need to take in a layer, but we don't need the addition here. So we're going to do that. And then the next, we can actually remove these things because we're going to probably have to type it all out. So let's remove everything, but I'm going to copy this part right over here because we are going to need this. So let's leave that. Let's take out the save layer and let's take out everything here at the top. Perfect. Now, something that I can't explain too well in this series is JavaScript or Node.js promises. Promises are basically kind of structures that returns a promise. Think of it. I promise you that I will teach you how to code. And then when I've delivered after this video, I can resolve it. I can say, cool, done. And then you will know that it's been done and so on. That's just basically a promise, right? In normal human language. But in computer language, it's the same. So we can say return a promise. Okay, so a promise. And what do we want to do and how do we want to return this promise? So a promise returns a function. So a function is just a normal arrow function, for instance, but it has to be asynchronous because we're going to put asynchronous code in here. And to be exact, we're going to put this code in there. So let's go and cut that out and paste that inside of our promise. Okay. So now what we have here is we're saying that we want this image to load, and then once it is loaded, please tell us that it's done, basically. So what you can do and how you do that in promises is you have a resolve and you have a reject. We're just gonna use the resolve. So you can call it just resolve, and we're going to use that resolve. We're going to put it there on line 50. And what do we want to resolve? At this point, we actually want to resolve something that the draw layer can accept, and we want to return an object. So we can say, let's just return a layer, and we're going to make it equal to our layer because we would like to know what layer this was before it loaded an image. And we're going to get to the image now, but we want to also maybe export a loaded image. Okay. So let's maybe just say loaded image, which should be this one. And that's going to be the image. What image are we looking for? Well, basically, this is now very simple. We already know the layer that has been passed to us. And at this point, we kind of want to just load the image at the file name. So how we can do that is we need to say layer. And now we do need to know where this comes from. So in order for us to complete this file is we need some kind of way of knowing which element to load, because previously we just loaded the image and we already handled the randomization before everything else. So let's go and create that function and then come back to this to finish this off. So what you can do is below this draw element, we can go and create a function, and let's call this I don't know what we can call this. Maybe construct layer to DNA. I don't know what we're going to call that. It is a very long name, not a good practice, but it's going to work for what we want to do. So that's basically what we want to do, right? We want to construct a layer from our layers config, which is sitting over there, and we want to remap these things. We want a selected element, which one has been selected, and all these things, right? At this point, we're probably not going to need the name and the ID. So go ahead and go to your config file and just remove that, because the reason for this is we are cleaning up, and whilst we're cleaning up, we might as well remove these because we want to reduce the metadata and we want to make sure that our code is nice and clean and doesn't take us a long time to set up. So we're going to remove all these names and IDs. We don't really need that. Perfect. Okay, so now we can go back to our file and let's go and open this up and see what it will need. So we will need two things. We will need a DNA and we will need a layer, because we want to see, we want to kind of extract the DNA like I explained before. We want to take that DNA and split it up in two 2s. For example, we want to take this ID or the DNA, whatever you want to call it, and split it up based on 2 digits each. Like so, okay? And then each one of these are going to be responsible for selecting a layers element. So if you look in your config file, we've got this elements, which is all the elements inside the files, right? For each layer. We want to look through there and grab the one that's closest matching to this. Now I know for some of you, you only might have one image in your layers. So, and in some there's 2, and in some there's a lot more, but I presume you have a lot more layers and images. So how do we get around that? How do we say 15 should, convert to 1 if there's only one image? We can use modulus for that, or matching and all sorts of cool things. But I'm going to show you right now how we can do it. So once the concept is clear, what you can do is we can say, let's DNA segment. Let's call this a segment. And we're going to say, well, we want to take this DNA that we're passing in and to string it. Okay. So we're going to string this and say match. All right. Just like so. So match, we can pass in a regex function. If you don't know what regex is, it's basically patterns that match a certain, how can I say, a pattern basically. If it matches, and then it returns, okay? So we can do this and like that. That's our start of our program. And we want to say we want to split this up. So this is going to give us an array of these patterns, okay? So just to show you what this is I'm going to, at this point, console.log this out. I know this is taking a bit longer, guys, but you know me, I want to explain everything explicitly. So what we can do now is let's go and put this inside of our base function over here, and we can immediately here after the console.log we can say maybe let result is going to be equal construct layer to DNA, and we want to pass in the new DNA, and then we also want to pass in our layers. For the first time, this is where we use our layers as apart from that now, but where we're actually going to use the layers that we import. We can get rid of this function now over here. So I'm going to get rid of that. I'm also going to get rid of that console.log, and we'll keep the metadata there. We're going to use it later on. Perfect. So I just want to console log the result. Okay, like so. And then I'm going to run it. So basically now you can see exactly what that function does up here so far. And where is it? There we go. So you can see there, and if you look here at the bottom, you can see that it's actually splitting up the DNA that is created into its different segments. 64, 07, which will just be 7, but it has to be 2 digits, and then it splits it up like that, and that's basically how it works. We're not done with that function yet. There's a lot to do still, so let's get down to the rest of it. Next, what I want to do is I want to actually create a function and call this mapped DNA to layers. Okay, what does this mean, and what do we want to return from this? Now, this is going to be a big thing that we return. Now, what we can do is we can say layers.map. So a map in an array returns an array, but you can map the values to anything you want to into new values. So that's the beautiful thing about mapping. So we are mapping through the layer, and I think this should be layers, not layer, because it's more than one. In here we can say this is a layer. Okay, we can refer to it as such. Inside this map, inside this basically this loop, we're going to create another variable. We're going to call this selected element. Okay, and the selected element is going to be now what we select. Now think about it like this. For each one of let me just think about this now. For each one of the layers, we map through this. Then we take the layer, which is selecting one of these guys, and we want to look inside the elements and get the closest thing to what the DNA says it should be. All right, and we can do that very easily by saying we want to take our layer, okay, and this is the layer now, our single layer, and we want to go and look inside the elements field. This is an array, so if we say 2, it will give us the element 2, 1, 0 will give us the first element, and so on. So the next thing that we can do is we can pass an int, okay, because that's at the end what we want. We want an integer. But how are we going to get an integer that tells us exactly what segment, what part of the segment we need to render from the elements? Now this is where it gets interesting. What you can say is you can say, well, the DNA segment, we can take the DNA segment and we need to pass it to int, because remember that's string now and we're passing it to int. And we're going to say the modulus of the layers, well, the layer dot element, so the elements dot length. Sorry, I'm thinking a bit about this, but this is quite a bit of hectic thinking, because we now need to say that basically this value might be something like 64, but the layer's length might be only 2 layers or 3 or 4 depending on how many images you have. So it needs to kind of say, well, the value of that modulus 3 for now, right, can give us a value between 0 and 2. And that's exactly what this does. So it selects that layer for us automatically. And now we had a good space to return. So we have to return here from the map first. So returning here will give us a new value to put in our map DNA layers. Okay. So we can now define our struct and how we want it to look like. Okay. So here we can say, cool, give us the not the ID, we want the location. Okay, and the location is going to be, well, we're basically going to grab everything from this, right? So we might as well just grab everything there. We can put it in here. And there we go. And now we can replace a bunch of stuff. And this is very easy. We can just do this. We can copy that and put that there. Copy this and put it there. Copy this and put it there. You want to keep these position and sizes, and the reason for that is because on a later stage we might want to use them. All right. We also want another element here at the bottom, which is the selected element, and that one we're just going to put like this. The rest of the things we have to append to the layer because we are basically just passing it along. After we've used it, we say, cool, we still want to know what your position is, what your size is, and all that good stuff. Perfect. And now lastly, after you've mapped, right, we want to return this whole array. Okay, so I'm going to return the mapped array, but first I'm going to console.log what this returns to us now. Because previously you've seen we've just looked at what does this section do, but now we're going to have a look at what the whole function does. So it already does this and logs out the results. I'm going to expand the terminal a little bit, run it again, and it can't find something. Let's look at it. It said it can't find the background. Now, where is that? That is in index.js and looking at the location. Oh, we haven't saved the file. It's important that you save it. Okay, let's go ahead and run it again. Perfect. And I just want to actually clear the browser and run it once. Perfect. So what happens now is it gives us back this list, okay, of all of the stuff that's needed, right? So it gives us back location, elements, and technically we don't even need elements at this part anymore because it's already used that. So let's go and take out those elements. We really don't need elements anymore. Okay, so we're going to take it out there in this function. We're going to clear the terminal again, run it once, and there we go. So these are kind of the things that we need, right? We need a location, which is the path to our element, and we need a selected element because by this time the program has already selected what exactly it should look like based on this ID. And I hope that makes sense, okay, thus far. Next, now we can actually go back into our previous function that we've started creating, which was the loaded layer function. Remember we had this and we were passing in a layer, but now where will we be getting that from? Okay, so we need to kind of go back down to our main section and complete our code. So now you know at least how the results look like. So what we can do now is we can say, well, for all the results, for the result, and maybe I must say results, it probably sounds better and works better. We can do a for each, okay? So we can say for each result, and a result is basically a layer, right? It is basically a layer that you've seen in the array. So for each result, we want to do something, and this is where we want to actually call our load layer function. and there it is, load layer image. Okay, so we're going to call the load layer image, and after we've loaded it, we can pass in the layer. Okay, and now we know what we're going to pass. It's going to be this object that we've constructed over here. Where is it now? Okay, it's going to be kind of looking like our layer that we have down here. So we have these values to work with. So now we can specify exactly what image to load. So we know that we have a location, which we put layer.location, and we know we have a selected element. So we don't want the elements because that was the previous code. So this time we have to say layer.selectedElement.filename. And that is perfect. That will load the correct file. But this function only loads the file. And now once everything is loaded, that's at the point where we want to draw it. But now, because you've seen how promises worked before, I'm going to introduce one more concept in promises, which is very much needed for us to complete this section. So the thing that I want to show is now we have to save each one of those promises, each one of these on line 110. We want to save in another array because they all will not complete in order. If we don't, they will just load, and once they've loaded, they're done, right? We want to save them and do something with the loaded images because that's our image that we want to concatenate. So we can say this is going to be our loaded, I don't know, loaded elements sounds fine, which we can make an empty array. Then we actually need to go here and say, well, in front of this, loaded elements.push. I know at this point it's getting a bit technical. I promise it's not going to get technical a lot more. But anyway, what we're doing here is in this for loop, well, this for each loop, we're pushing to this array each one of the promises. Now remember, this is a promise, okay? I'm just going to do this so that you can see what it is, because I want to leave little comments maybe just for you to look back at and remember that this is a promise array. Okay, well, that is the promise array, so I'm going to do it there. Okay, so that is the promise array. Sorry, and copied the wrong thing. Like so, and this is just for you guys to remember what it is. Now we had a very good space to draw, right? But how do we know when all these promises are done loading? How do we know when all the images are ready to load and we can start drawing them all once? Well, there's one thing we can do, and that is to call a function on promises called all. So you can call promise.all. And what promise.all does is you can see it takes in an array of promises, and that's exactly what we have. So we can pass this in, and we can say .then, okay. And we now have to specify, we can just say element, okay. So we can say once the promises have resolved, okay, each of these elements, but we can call it elements because this returns the whole array. So actually, I'm going to call this element array so that you know what this is. So after everything has resolved, we're going to take the elements array and we're going to do another for each. This time we're going to take the element and we're going to draw it. So this time we can say draw element, and the draw element, remember, we've defined up here. There we go, there it is. And just to give you guys an idea now, our elements look like this. So we can technically go and say, well, element dot what did we call this? Load image. And then this is element dot layer. Okay, that's element dot layer, and element dot layer. You might wonder where I'm getting these from. Remember that we've concatenated this object. So we have the layer and we have a loaded image. Well, it's a loaded image, so we need to say loaded image, what it needs to draw. And then this is going to go and draw all these things on the right, widths and heights and everything. Perfect. Going down here again, we need to pass that element in there. And once we've done that, we're basically done. So the last thing that we just need to do is inside this promise, after this promise have resolved, that's where we want to do a few things. That's where we want to save the image now. Okay, so I know this is called save layer, but we can now call this a save image. And let's just go and replace save image right at the top here where it says save layer. We can replace that with save image. And the reason is because it's just, it's just much better. And next, we don't have to use canvas in here. We don't have to parse it. I know we are creating pure functions, but some of the top level elements such as the layers and the global canvas, we can just make use of directly. Okay, so we can change that out. And then this one, we need to pass in an addition count. So I'm just going to refactor this as well and just call it addition count so that we know what we're passing in. So let's go back down to where we say save image, and here we need to pass the addition count. Okay, so once we've done this, it will save our image after all of our images has loaded. It will draw it in the array, and once it's done, it will be happy, it will save it, and it's performance saving. All right, that's very important. We also said we are going to add our metadata. That we can add right after we've saved our image. So we can uncomment our metadata. And because we're still in this loop, let me just think about this now. We still need to pass in the ID and or the DNA. Let's just see what we are doing with the metadata, because metadata before was a bit different. So let's go and see. Okay, let's add attributes and let's add metadata. Okay, so this does look a lot different, which we'll have to change. Okay, so like I mentioned, we probably have to change the metadata function. It is fine as it is, but there's a few things that we don't need anymore that we're going to change. For starters, we need a DNA field because we don't have a hash anymore. So we're going to get this DNA right from passing it in at the top. We're also going to pass in the addition. So let's go and swap out this hash for our DNA. We're going to leave this decoded hash and take it out. We have the addition, which is now the addition that we're dealing with, and we have a date and an attributes. We don't need to push this metadata over here. Let me just think about this. Yes, we do need to push it still, but it doesn't seem like a nice name to have. So let's go and change this metadata list to actually metadata list up here as well. And let's do the same for attributes. Okay, we don't need the hash and we don't need the decoded hash. So let's go down to our metadata function, and when we look at it here, we're going to need to clear the attributes, but we don't need the hash and we don't need that, and that's basically all we're going to need. Lastly, I did mention that we can push down here our DNA, so I just wanted to double sure that we are doing that, but we kind of want to do it right after everything has rendered. So we're going to take this out and move this right up here where our metadata gets added. This way, we also will know that this happens right after the metadata and everything is working fine. Otherwise, if something breaks, it might push that too soon. And that's all that we need. We need to remember to change attributes to attributes list. And then let's have a look at the attributes function as well. So this one, this attributes function doesn't need this layer anymore, and we don't need this temp object anymore as well. Basically, all we need is a, let's actually take this out and let's rewrite this. We're going to need a selected element, okay? And the selected element that we need is going to come from the elements.selected element. And once we have that, we're going to say attributes list.push, and we want to push a smaller object this time. We're just going to push the name, which is the selected element.name. And then the second thing is the rarity. Okay, and the same for that goes selected element.rarity. Rarity is we get from the config file once we load the config. You'll find that how we did this in the previous tutorial. But anyway, now that we have this, I think we are all set up. We just need to remember to go back because we need to add our metadata arguments. So let's go down again and let's see. So our metadata now is going to take the new ID. Well, I keep on saying ID, but it's the new DNA. And then it's going to need the addition count. And that's basically what we'll need there. After we're done here, we've basically created the image. So I want to put this console.log down here and just maybe say we've created the addition and then pass it that addition, right? We can maybe say with DNA and then also pass in the DNA, just so that we can see what we are doing and how everything is working. We can leave that console.log there for if something goes wrong, and then we can just close that to neaten up our code a bit. Now this function is a bit big. You can split it up if you want to even further, but this is good enough for now. I want to quickly take a look at a very last concept, and that is to write on our NFTs. But before we do that, I want to run this and actually see if we've improved the performance. So let's go ahead and let's go and clear out our images in our output folder. Let's go and clear that out. And there we go. And I'm just going to clear the terminal and let's create two. We do get an error, and let's go and see why. So when we go down into our function over there, let's just go and have a look. Okay, it's because it's writing to the metadata over there. But we can even better this function as well, because we need to clear the metadata before we write to it. So let's give this a data attribute, and let's put the data over there. So we're gonna cut this and, well, let's put the data over there, okay, like so. So we're going to write the data. So where we call this is right here at the bottom. Remember, we had this at the bottom, but we most probably can change that now. So we need to pass in the JSON and the metadata, but remember, we called it metadata list. Cut this function out, and we want to put it right after our function ends, like right there, because this means everything ran, our metadata can now be saved. We want to also call this metadata function right in the beginning. So right here, when your function starts off, over there, not in the while loop, sorry. right above this declaration, we can say write metadata should be empty. This will clear the metadata file every time that we run our program. And that's kind of what we want. We want all this stuff to be cleared out. So let's go ahead and run this file again. We have another error, which is perfectly fine. So I just want to see what that might be. Cannot read property name of undefined. And this is now where we quickly have to do a debug. So debugging code is extremely important, and it is very crucial for you to know how to debug and how to make sure everything works accordingly, right? So let's go and see what did we do wrong and why are we getting this cannot read property of name. So a good thing to do is actually to start off with the thing that it's complaining about. And here we can see that we have in our attributes file, we've got a name, which is .name, and I don't think we have it anywhere else. And we can say, yes, indeed we do, because the selected element over there is the selected element.layer, not just selected element, right? Well, there it is, selected element.name, but there it is layer. So that one should include layer, then we get it, and then we pass it in there. Okay, perfect. Hopefully this resolved everything. I'm going to clear the terminal and run it once more. And there we go. We have one image, but it's still broke, so we're going to debug again. Attributes is not defined. Okay, it is not defined. So we're going to search for it, and we find it in our metadata. That is true, because we don't have attributes anymore. We have attributes list. These are little errors that we've created for ourselves, or I would say I did, but it's good because it's better. All right, I'm going to run it again. And we have a new error, so we're going to have to debug that one. We search for new DNA, and this one's going to be a bit more difficult to find. So let's just quickly see where it could be. Okay, not defined. So there's the new DNA. Create the DNA is that. Let's just make sure that we are returning our rand number. We are. We're passing it in there. We go in here. We have our DNA. We say, is it equal to DNA? Found. Yes. Okay, have we even ran this? So a good practice here would be to actually console.log it before we execute the program. So indeed, it says undefined, which is fine because it should be undefined. That's fine. So that DNA is not the problem. Let's go downwards. So let's go to the construct layer DNA. We're going to go in here. We're going to see there's the DNA. DNA.toString, and it matches. This seems all fine because it worked right before. So it's not that's not the issue. And then we get into the new DNA there. Okay, and then we also console.log the new DNA there. Now, it can be one of these two, but I highly doubt it. So here we go. That is the problem. Remember, in our add metadata, we moved adding to our DNA list. We have to pass the argument DNA that we pass in it. I think this is the last error that we'll get. So let's run it, and yes, there we go. And I'm very glad that we actually got to see that. It's very cool that happened. Actually, now that I think about it, there's one change I would like to make. Sorry for that. In the metadata, adding to the DNA list is not going to work over there. So cut that out again. And we need to move it inside here. in our if statement, right after our if statement ends, just before the count goes up. Okay, so just before there, we want to push the new DNA. I'm so sorry about that. I just saw that that was going to be an issue, and I saw that actually because we had two empty arrays rendering, and we should not have empty arrays. They should fill up, right? And that is perfect. So it should have filled up with the last one, but because this was the last one that got rendered, it was fine. If there's 3, so for example, if there's 3, there will be actually 2 in there. Perfect. One thing that we can see that is not working really well is that it keeps on saying that we are rendering edition 4 over here, over 4 and 3 and 3. It's not incrementing kind of how we wanted to increment. Now, why could that be? It's either because our while loop, we are incrementing in the wrong places and we need to do it a bit differently. So let's quickly have a look at why that is. So I'm sure you guys have had a hectic session with me this video, figuring out all these new concepts. I did figure out the error, and all it was we forgot to make it async this function and await for all the promises. So all you need to do is at line 109 over here for my code, you can just say await. And then remember to make this function, the start creating function, async. So it's able to do that. And once you save that, everything is perfectly okay and 100%, and it's optimized, it's ID checkable, and it's really, really fast. So let's go and run it. So in the terminal, let's go and create 3 images. So we can say node index 3. Once we run it, you can just see how fast that is. It's already created them. Like before, if I selected this image and I run it again, you will see that it immediately changes. You might have noticed in the previous tutorial when I ever select an image and do this, and if you run it yourself, you'll see the actual layers build on top of each other, which is not really good for RAM and memory in the computer because it saves almost 7 times, especially if you have 7 layers. The more layers you have, the more times it saves on top of a image. This program allows us to save only once. And to prove its efficiency, I'm actually going to quickly here demonstrate how we can quickly render 20 while I explain what we'll be doing next. So I'm going to enter 20, and you'll see it accumulating and rendering the 20 images. And before I could finish a sentence, it's done. So you can imagine how fast this was. In the previous one, it would have taken at least like half a minute, 30 seconds, 40 seconds. Plus, the longer it goes on, the longer it takes. And this doesn't happen in this case. So I hope you enjoyed this video till this far, but I do have something extra to show you, which is actually writing on top of the image. As a bonus to this video, I want to actually show you how you can also add text on your images. I'm just going to, for now, remove all of these images because they take up a lot of space. Once they are removed, and also just taking a look at the metadata like before, this metadata array also looks much more cleaner. It only has the DNA, the edition, the date, and the attributes with their rarities, and that's all you really need. You can go and customize it as you like. But anyway, going back and adding a signature is pretty simple. All we need to do is kind of make a space to kind of sign the image here after our images have drawn. And remember, this is where all the images layer, and then afterwards we can actually draw an extra layer on the canvas, and that's what we're going to do here. We can call this maybe sign image, a function, and what we want to pass to this is something like this, where we can maybe say the edition count, for example. Next, what you can do is create a sign function. So let's do it here at the top. We can say this is going to be the sign image function, and this is a very simple function. First, it starts off with ctx, which grabs the context of our canvas up here. Okay, and then the first thing we want to do is say full style, and the full style is basically the color that you want to write in. So we're just going to do that. That's black color. The next thing you want to do is actually define your font. So you can say ctx font is equal to, let's make it bold, maybe 30, like so. Okay, and you can also specify any font style as well, like Arial or Courier. Let's just do that as an example. So here we can also say Courier. Okay, and then you can say ctx text baseline. Now this is important, and to set it to top, because otherwise your baseline of your image alignment is at the bottom, and it's very hard to align stuff from left and the top corner, because you want to give it a little bit of a padding. Next thing that you can do is say text align. Okay, and we want to align the text always to the left. This is by default left, I believe, but just to make sure. Then we want to say the full style is, well, full style we've already declared, full text. Now full text is actually the part where it writes the text, so we need something to write. We're going to call something up here called sig, which we've passed in once we've called this a function. And this you actually call like a function. You pass in what you want to write, and then the x and the y value. So we're just going to make it 40 and 40 to give it a nice padding space at the top. And that's all we really need. If we run this now and we say we want to have one image created, we will see that our one image has the number 1 at the top. And if we go and create maybe 3, you'll see that 3 creates very fast. There it says 3 at the top, 2 at the top, and 1. And that's how you can write on your images, with creating a little extra layer and doing so. Another thing that I see is popular in the art generation world is actually creating functions to create backgrounds that are like pastel colors. And I'm quickly going to explain how to do that. What you want to do is you can create maybe a draw background function, and in this draw background function, it's going to be pretty simple. It's much the same here at the top, right? We're also going to have a full style. This time we're going to set the color to something, and then you have ctx.full rect. Full rect will just draw a rectangle from 0 to 0, and then we want to pass it in the width and the height of our canvas. All right, where do we get the width and the height? We get it from the top here. We import it from our configs. Okay, perfect. But what color do we need to draw? Well, we can create a separate function for that, and we can say, well, this is going to be gen color, and this is where we can generate a pastel kind of color. So in order to get that, we can specify a u, which is just going to be math.floor, and we want to get a value for the u first. So we can say that this is going to be a random value, and the u's go from 0 to 360. So we can say that the u is going to be a random of that, and then we get the pastel color that we want. So you can play around with these values and you'll get different hues and shades. But we're going to use this color format, which we now need to string interpolate. So let's just do this. And that. And let's say this is the HLS bracket, and then we're going to end the bracket. And we need a few values in here. So we're going to need the u, which we specified in here, separated by a comma, and then we can just make this 100% and 85%. I found worked very nicely. And lastly, we want to return the pastel color. And then all you need to do is call it in here. So we're going to get the color. Now, where do you draw this, you might ask? Well, it's very simple. Once you get used to this program now, here at the bottom of our file, where we have all the promises resolving, what you want to do is, before you start looping over your elements and drawing the layers, you can just basically call draw background. So I'm just going to test run this, and it looks fine. It ran. You won't be able to really see it in the back, because remember, we have a background layer, which is always, if we look at our inputs in our backgrounds, it's a black image. But we can always go to our configs, and if I go down to my layers and I remove the background layer, like so, and I save it and I run the program again, then you can start seeing the pastel colors behind the eyes. And it becomes even more apparent if I take away maybe the top and the bottom lid and then run the program. Then you'll have very naked eyes, but at least you'll have these nice pastel background colors. Now, I hope this was a very interesting tutorial, upping your game with this NFT creator. Like I said, I'm going to now upload this code exactly how it is to GitHub in an open source folder called generative art or something, and I'll put the link in the description. If you really enjoyed this video, please stay tuned, please subscribe and put on that bell icon, because it's really important for me whenever I want to teach you guys something that you guys are notified about it. I'm heading to bed, guys, and I hope you guys have an amazing day. Cheers for now.